Welcome students. I am Professor Maya. Today we will learn how to write and balance chemical equations, making chemistry much more concise and useful. Remember our activity 1.1. When a magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide. But describing this in a sentence is quite long.
Professor Maya, writing full sentences for every chemical reaction takes too much time. Is there a shorter, more efficient way?
Excellent question, Sneha. The simplest way is to write it as a word equation showing reactants transforming into products. The word equation for activity 1.1 is magnesium plus oxygen gives magnesium oxide. Notice reactants on the left, products on the right.
So, Professor Maya, reactants are the substances we start with, and products are the new substances we get after the reaction.
Perfect. Arjun, reactants are substances that undergo chemical change. Products are the new substances formed during the reaction. In word equations, reactants are written on the left-hand side with plus signs between them. Products on the right-hand side, and the arrow shows direction. But there's an even shorter way. Chemical equations use chemical formulas instead of words, making them more concise and useful. Using chemical formulas, our word equation becomes Mg plus O2 gives MgO, much shorter and clearer.
Let me count the atoms. Professor Maya, are the number of atoms of each element the same on both sides of the equation?
Good observation. Sneha, left side has 1 magnesium and 2 oxygen atoms. Right side has 1 magnesium and 1 oxygen. This is unbalanced a skeletal equation. Remember the law of conservation of mass from class 9 mass cannot be created or destroyed in a chemical reaction. So we need the same number of atoms before and after.
So, Professor Maya, we need to balance the equation to make the number of atoms equal on both sides of the reactions.
Exactly right. Arjun, balancing ensures mass conservation. Let me teach you the step-by-step method for balancing equations. Let's practice with a more complex example. FFE plus F2O gives a Fe3O4 plus H2 gas. This looks more challenging to balance. Step 1. Draw boxes around each formula. Very important, never change what's inside the boxes while balancing. Step 2. Count atoms of each element. Iron 1 on left, 3 on right. Hydrogen 2 on left, 2 on right. Oxygen 1 on left, 4 on right.
Professor Maya, which element should we balance first? There are several unbalanced elements to choose from.
Step 3. Start with the compound containing the most atoms, Fe3O4. In that compound, pick the element with most atoms, oxygen. We need to go from 1 to 4 oxygen atoms. To balance oxygen, we need 4 oxygen atoms on the left side. So we use coefficient 4 in front of X2O, giving us 4F2O. Now we have 4 oxygen atoms on each side.
But, Professor Maya, now the hydrogen changed too. 4A2O means we have 8 hydrogen atoms on the left side instead of 2.
Excellent observation. Arjun, step 4. Balance hydrogen. We have 8 Fe atoms on left, 2 on right. So we need 4 8, 2 on the right side to get 8 C atoms. Step 5. Only iron is left to balance. We have 1 Fe on left, 3 Fe on right. So we need 3 FFE on the left side.
Let me verify the balanced equation. Professor Maya, I will count all atoms on both sides to make sure everything is equal.
Step 6. Verification. Left side 3 Fe 8 F4O, right side 3 Fe 8 H4O. Perfect. This is now a balanced chemical equation. This method is called the hit and trial method because we make trials to balance the equation using the smallest whole number coefficients.
Professor Maya, can we show in the equation whether substances are solid, liquid, or gas? Can we make equations even more informative?
Excellent question. Arjun, step 7 we can add physical states. S for solid, F for liquid, G for gas, and AQ for aqueous solutions in water. Or complete balanced equation 3Fe solid plus 4E2O gas give Fe3O4 solid plus 4F2A. Notice X2O gas means water as steam. We can also show reaction conditions like temperature, pressure, or catalysts above or below the arrow, like this example showing 340 atmospheres pressure.
Professor Maya, can we practice by balancing our original magnesium example? Mg plus or 2 gives MgO.
Great practice idea, Sneha. Left side 1 Mg, 2O. Right side 1 Mg, 1O. To balance oxygen, we need 2 FgO on the right side. Now we have 2 Ng on the right, so we need 2 Ng on the left. Final balance equation 2 Ng plus 2 gives 2 MgO. Perfect balance.
Adding physical states to be complete 2Ng solid plus or 2 gas gives 2Mg solid. Now it's a fully informative chemical equation.
Today's key learning, we progress from word equations to chemical equations to balanced equations, always ensuring we conserve mass and atoms.
I understand now, Professor Maya. Never change the formulas inside the boxes. Only add coefficients. Use the hit and trial method to find the right numbers.
Perfect understanding, Sneha. Chemical equations are the language of chemistry. With practice, you'll become fluent in writing and balancing them. In our next lessons, we will explore different types of chemical reactions and see how balanced equations help us understand the chemistry happening around us every day.